So this lesson is called Polynomials and Measurement. So looking at the perimeter here, determine the simplified algebraic expression for the perimeter of the following shapes. Then calculate the perimeter with the given values. Okay, so the first one we have, this side is 2x plus 3, and if this side has the same two dots, that means that this side is also 2x plus 3. So 2x plus 3. And if this one has one line and it's an x, and this one has one line and it's an x, they're also the same. Okay, so perimeter, where's my little marker? Okay, perimeter equals, the formula is 2 times the length plus width, okay, because we have 2 lengths and then 2 widths. So let's go W, length, length, okay? So 2 times the length is 2x plus 3, so 2x plus 3, and then plus, because the formula has a plus, and then we have to add the width. Well, the width here is just x. Okay? So now we keep the 2 out in front because we know there's 2 lengths and 2 widths, but we're going to add everything up, collect the like terms. So here we have 2x plus another x, so we know we have 3 x's, and then still plus 3. And then next what we have to do is we have to multiply everything in the bracket by 2. So the first one, 2 times 3x gives us 6x. And then 2 times positive 3 gives us positive 6. Okay? So this is our final answer here. But part B, it says, calculate the perimeter of the rectangle if x is 3 centimeters. So I'm just going to rewrite this down. Our perimeter was 6x plus 6, but now where we have an x, we are going to plug in 3. So perimeter equals, instead of 6 times x, it's 6 times 3, and then still plus 6. Well, in your calculator, 6 times 3 is 18, and then we still have to add plus 6. And then when you add these all up together, 18 plus 6, you want to use your calculator just to be sure. I just like using this every once in a while. Okay, 18 plus 6, I look so fancy, and you get your final answer of 24. And because they are dealing with centimeters right here, we have to put centimeters in there. So our whole perimeter is 24. Okay, you could have also used just the formula perimeter equals width plus width plus length, and you'll get the exact same answer. I just chose to do it this way. Okay, so let's go to our next screen. So here we have to calculate the perimeter. So the perimeter of a triangle is adding up all 3 sides. Okay, so we'll do this one first. Okay, so 2x, that should be a minus, minus 1, plus, let's do the second side, 4, plus the third side, x plus 3. Okay, now because there are no numbers in front of these brackets, it's assumed that it's a 1. Okay, so we can actually just rewrite this without the brackets. So 2x minus 1 plus 4 plus x plus 3. And now we are going to collect our like terms like we had done before. Okay, so here is an x, and here is an x. So 2x plus x, and then we have our constants left over, so negative 1 plus 4, negative 1 plus 4, and then plus 3. And now when we add these all up, 2x plus x gives us 3x, and then in your calculator, negative 1 plus 4 gives us 3, and then 3 plus 3 gives us positive 6. Okay, So this is the total perimeter of the triangle. But now we are going to calculate the perimeter of the triangle when x equals 0.5 millimeters. Okay? So perimeter equals, we have 3x plus 6. And now where we have an x, we are going to plug in 0.5. So 3 times 0.5 and then plus 6. So in your calculator, okay, so 0.5 times 3 gives us 1.5. And then we still have to add on 6 from here. And when you add those two together, you will get 7.5. And because we're dealing with millimeters, our final answer is in millimeters. Okay, let's go to the next one. So area. Determine the simplified algebraic expression for the area of the following shapes. Then calculate the area with the given values. Okay, so this one right here is a rectangle. Okay, so perimeter of a rectangle is length plus width plus width. So, oh, sorry, area we're doing, not perimeter. I'll be okay. It's just length times width. Okay, and then here we'll call this the length. We can call this one the width. So the length is 4x minus 3, and then multiply it the width, which is 2. And now we can multiply everything out. So I like to write it the other way, just it makes it less confusing for me, but it can work either way. So I'm just rewriting it this way. So 2 times 4x gives us 8x, and then 2 times negative 3 gives us negative 6. Okay? You could have done it this way. 2 times 4x, and then 2 times negative 3, you'd get the same thing. Okay, so now we are going to calculate the area when x equals 2 meters. So we're going to bring this over here. So, oh, this should have been an A. Area. Okay. So now area equals, we have 8x minus 6, but everywhere we have an x, we are plugging in a 2. So now it's 8 times 2 minus 6. And then when you multiply these, 8 times 2 is 16, and then we still have subtract 6. 16 minus 6 gives us 10, and because we're dealing with meters, we have meters, and because this is area, don't forget it's meters squared. Okay. Let's go to the next question. So this one, we are going to calculate the area here. Now this one is a composite shape, so it just means that there's 2 or more shapes making up one shape. So I usually like to just draw a line across. So I'll separate it. We'll call this one shape 1, this one shape 2. Okay, so when we're doing this, I will call it area 1. And that is a rectangle, so it's length times width. And if we look here, these have the same lines on them, so that means that this length and this length are the exact same. Okay, and also this length is the exact same. So because up here is labeled an x, that means that this dimension is an x and this dimension is an x. So our length is x and let's just do length and width, so it's x times x. So this first one is x. I'll just put a dot to separate. That also means multiply times x. So remember, when you multiply variables with the same base, you add the exponents. So 1 plus 1 gives us x squared. So the area of A1 is x squared. So now we'll do the area of shape 2. So we know it's the same thing, a rectangle, length times width. Okay, so now we're going to have the length and the width. So the length is 3x minus 2, and the width is x, but I'm just going to do it reverse. So I'm going to do x times 3x minus 2. Okay, so I just like it this way better. So I'm now going to take x, multiply it by the 3x. So I'm going to have 3x squared. And then x times negative 2 gives me negative 2x. Okay, so the last and final step is the area total. So that means area 1 plus area 2. So we need to add these both together. So area 1 was x squared plus area 2 was 3x squared minus 2x. So now we can rewrite this without the bracket, because if there's nothing in front, it's just a 1. So multiplying anything by 1 is not going to change it. So you're just left with x squared plus 3x squared minus 2x. And then we'll collect our like terms. So we have x squared plus 3x squared gives us 4x squared. And then we just have minus 2x. So that is the area total. Okay, so now we are going to use this up in here. Calculate the area. I'm just going to draw a line here just so we don't cross in. The area of the figure when x equals 2.5 centimeters. So let's plug it in. So area total equals 4x squared minus 2x. And wherever we have an x, we are going to plug in 2.5. So 4 times 2.5 squared minus 2 times 2.5. Okay, and then in your calculators, we have to think of BEDMAS. So brackets first, and then exponents. So 2.5 squared, so it's going to be 4 times 6.25. And then subtract, we have 2 times 2.5. Okay, leaving that the same. And now we're going to multiply these together. 4 times 6.25 gives us 25. Subtract 2 times 2.5 is going to give us 5. And then 25 minus 5 gives us 20. And because we're using centimeters and its area, it's centimeters squared. Okay, next one. Determine the simplified expression for area of the shaded part of the figure, then calculate the area if x equals 1.25 millimeters squared. Okay, so I'm going to pause this and start recording on the second video because I don't want to be timed out.